Okay, welcome to toddfun.com. Hopefully this will be a quick one. The radio in my Jeep no longer has a display, yet the radio works perfectly fine. It tunes and plays CDs and everything works fine. The display is dead. It's got the markings on it. It looks like if there's two jacks, these are mostly for speakers, these are for speakers, and something called mute, which isn't really there. It's not hooked up on my car. I'm not sure what park is. Illumination, I believe, is hopefully for the display. It only gets power when I turn the vehicle on. I didn't check for auxiliary. I'm not sure what that would be. I guess I should find out more. And of course the battery. This has battery power 24/7 because it keeps the memory of your channel settings that you have. So I did check. I got battery, and this illumination or this ILL comes on when I power up the vehicle. So let's crack it open and see if we can figure out where the voltage isn't getting to this vacuum fluorescent display that this has. Well, I'm not going to say much I can see here. I don't really fix radios often enough to be an expert here, so I can see the antenna comes in here, and then there's an antenna and a wire coming over to this box, this board here. So obviously this is going to be part of the pre-tuner for the radio. They're labeled, this connector that I'm mostly concerned with, that one that was called auxiliary is actually called ignition, so obviously that one that I didn't know what it was is just another ignition sensor that you've turned your ignition on. Not going to be able to say much more. You got a sort of a big returning pot up here for your volume. You got two big, these are going to be left and right audio channel amplifiers on the side, sandwiched between this giant heatsink. This whole side of the radio is a heatsink. There's actually nothing there but a heatsink, a big piece of chunky piece of aluminum. Let's just dig deeper. Okay, I guess I didn't have to take the little button caps off. This whole thing comes off. Well, I had to take off the volume button, but I didn't have to take off the equalizer buttons because it's just a board. It's got plugs in right there, and the display is in there. I would say that if you can get in real close, you'll notice that there's some silk screening there, and I'm mostly concerned about right above my finger there. There's a 5 volt and a 12 volt, and it looks like a P ground. I'm going to assume that's a 5 volt supply, a 12 volt supply, and a panel ground. Probably could just see if that powers up this thing from there. A lot of the other stuff I think is just for the buttoning controls and stuff like that. So let's take it apart some more and see if we can see anything else. I certainly don't see anything. I could see some gook, but I don't see any broken, burnt traces or anything. And this is the panel that's not working. Looks like we still have our little dot saying that we got good vacuum. If that turns basically white, you've lost vacuum. But there is a little bit of rainbowing, which means it's done its job for so far. So this is obviously the display controls chips. Okay, through a little bit more testing, this pin that's marked auxiliary is actually marked ignition. That's the third pin in. So the first pin is battery always. The middle pin is auxiliary, which is actually ignition on. The third one is lamp. That's mostly when your headlights come on. So just to make powering this thing easier, on the back of this nice convenient uprise board, this riser board, I just soldered a wire across all three of those, because once they all get power, you're basically your battery's hooked up, your engine is running, your vehicle's on, and you have your headlights on. So that'll give me a good test point to see if I'm getting voltages down here. Now I'm going to check to see, do I get the 5 volts and 12 volts I'm supposed to get from here per the silk screening on the other board. Have the power hooked up here now. So I just have this one wire going across all those, and then I got my ground back there. And down in front I have wired in where the 5 volts is silk screened on this, and sure enough I'm getting 5 volts. So let's jump over and test the 12 volt one. That should be a couple over. Okay, now per the silk screening I'm jacked into the 12 volt point, and I'm not getting quite 12 volts. It's a little bit of a drop, but I suppose it's got to go through a lot of other things inside. It's down to 11.5. Certainly it would be enough to drive whatever is necessary on the screen. So being I know I'm getting the voltages that this thing is supposed to have, I can't swear that the current can get to it, but if it's getting the voltages, we're probably pretty good. We'll probably just have a simple dead display. Well, quite interesting with my little rig up for power here. I'm getting about an amp at 12 volts through this. All the illumination lights up for the buttons, and the equalizer lights up fine. Everything's working except for the display. So now I'm curious, are the vacuum fluorescent chips that control the data that goes to these fluorescent points functioning? And that is, will the anodes actually be getting voltage? If they are, they'd be essentially putting a positive charge behind that phosphorus where they want to light up, and then provided everything else is working, they'll light. But not everything may be working. If the anodes are working, that leaves potentially the cathode, the component that actually makes the electrons that actually will then essentially stimulate the phosphorus to glow. But more importantly, is the actual chips getting the analog or the cathode signal to actually be lit. Right now, I have a little micro clip hooked up to one of the data lines going down to essentially the display. And you can see over there it's showing 11 volts, 11.2 volts. So it basically is trying to light up that pin right now. But that doesn't necessarily mean it's actually functioning as a proper radio. So what I'm going to do now is I'm going to hit the scan button as if you're going to scan through the radio frequencies. And if that changes, then we know that the actual display and the radio are working. And there you see the voltages over there are changing as it scans through the stations, as it's changing the digit that particular anode pin goes to. So that means that the cathode, the part of this vacuum fluorescent that's supposed to generate the electrons, is not working. It's supposed to heat up a special type of metal in there that's the cathode of this vacuum fluorescent display, and that cathode then, you won't visibly glow, but it will actually get hot and it will emit electrons that then are being sucked into whatever is getting lit by this voltage here, and then that phosphorus would glow. So now what's wrong with the cathode of this vacuum fluorescent display? Okay, I got the front panel off again, and if you can see in there real good, you can see there's like 5 wires going across the screen, and they connect over here. And that's going to be the heated cathode that goes across those wires, and they pop out up here at the top, and they're wired in across that plate in the back, and they just hover above everything, and that's what produces the electrons when that gets heated. And then of course the rest is with the data pins, and there's like a mesh in there that's between those letters and that heated wire. There's a mesh that also gets, it's also an anode, it also gets a positive charge, and the combination of the two draw those electrons down through and impact that phosphorus material. So next thing is, am I getting my voltage necessary to heat that cathode wires? On the back side, I've traced, I have a better pointer, these 3 are would be the positive, or essentially where they're going to power that heated wire, and it goes up to this spot, goes across that cap, comes over into this resistor, and then into the second pin on this chip here. And all these components test fine, all these traces look good. And then on the other side it pops out at this up here. And it just comes down and ties to the same thing and goes to ground. And so my next plan is I'm going to hook it back up again, and I'm going to see if I can start applying some voltage to this, heat up that cathode, and if everything's working, the display should light up, but I'll have to do it with a separate power source. I don't know what's wrong, I don't know why. If that's it, I don't know, I can't fix it. It'll be time to go to the pick apart and pull the old radio off a junker and take this panel out of it. Okay, I'm going to essentially power that heated element that should produce the electrons for the display. I'm going to do it myself. I'll probably destroy the thing if there's something wrong anyway, but that's fine. This display is pretty useless at this point. So I want to get on tape in case you get the magic blue smoke out of it. I have my dual power supply, so I got 12 volts which will power everything, and then I'm going to turn up that heated element, that cathode, and see if the display starts to light. And you know, it should be basically, as long as the voltages don't get too high and you don't overheat that element, it should start producing electrons through those wires, and then the display should light. So let's give it a shot. Blue smoke or not, here we come. Okay, we got lights on everything. Just doing a little health check. I'll go ahead and make sure it's in the AM radio, make sure it's scanning, and now I'm just going to start turning up the voltage on the cathode. I have a current limit set on my meter, or my bench power supply, so it will stop at a certain point. Okay, we're up to like half a volt. Oh, look at that! I'm only up to 0.7 volts, and you can already see it scanning. So that's 0.7 volts, and it's you clearly see it's scanning just fine. Let me take up a whole volt maybe, so we get a little brighter. I don't want to go too hot with it. Yeah, that's about as hot as that. It's 0.8 volts. So on my second wire we see about 0.8 volts, or about 100 milliamps, and that's making the display work. So it is those 5 wires, or the cathodes that have to heat up and produce the electrons, is the only thing that's failing here. Okay, I soldered on see if it'll focus. Okay, I soldered on a little jumper wire to the closest to that chip as possible that goes down, and it routes through the few passives and down to where it should be providing that 1 volt. Well, it's 0.8, but I went up to 1 volt, was fine too. Nice and bright at 1 volt. Probably goes higher, but I didn't want to push it. So then I will go ahead and just put this on, and I can measure to see if I'm getting any voltage coming off of that chip at all. That'll tell me if there's something else going broken farther down. Okay, I've got my jumper wire hooked up. It's tapped in right at the chip that should be powering the display. The ground clip is there, and I got my fluke hooked in, so it should show any DC voltage right at that chip. And everything comes on. Ooh, that's interesting. We're getting voltage at that chip. Okay, I moved my jumper over to the other side of that first component, which was a 6.8K surface mount resistor. I'll plug in the power here. Everything comes up, but no voltage. Okay, I just heated both sides until I got both sides hot enough to lift it off. Now let's test it. Okay, this is the little bit that we have to test. Let's see. I got my meter up here. You won't see it, but I'll tell you what it reads. Get on that little bugger. Well, it reads 6.76 K, and it's supposed to be a 6.8 K. So that is clearly not a problem. But my suspicion was that it was going to be the now I gotta go find it. Well, I unmounted the surface mount that was right there, and it tested fine. And then I used a solder wick and got all the solder off and was pretty careful at getting out this electrolytic, but the electrolytic was underneath in there where that little circle is, and so I pulled it out pretty carefully, but unfortunately one of the legs pulled off. But it seemed like it almost just came out, almost like it was bad, because I didn't pull on it that hard, but pulling at an angle, it's kind of hard to know. So yeah, get the polarity right on the marking and try and get another one, I guess. Okay, I put a new, or it's kind of hard to see, maybe I'll focus, maybe I can zoom in on it. You can see right there I have a new 1 microfarad capacitor in proper orientation. It's sticking off the side, but there's room for it. And I took off all the other capacitors and tested them. They're fine. So no trace problems, no passive problems. I'm going to plug it in now and see if we have any luck. Not looking like it. So what I'm going to say at this point is that it's either something I'm not seeing, and there's supposed to be voltage coming from someplace else, and I really don't see where. There can't be. But being this is a double-sided board, and there is a few vias, it could be something on the other side underneath this display I can't see. Well, I did some more testing, traced some more voltages. There's 2 chips on here. I think the second one is bad on the back of this panel. Really not something I can fix. So I went to the pick-apart junkyard and I pulled this one off of another Jeep 1 year earlier than mine, but other than that it was an identical vehicle, identical sound system, but this is 1 year earlier, and even though this panel looks identical, they are definitely different. This panel, I can't use this particular one. I got it for $17 because it was junked out. The volume and on-off is broken. The panel is smashed on the side and across the top where it mounts. It was beat up pretty bad, but I only really wanted this anyway. I wanted to take it out and stick it on mine, but it doesn't fit. These pinouts are literally shifted over just a little bit this way, and they won't line up. And the boards are actually different in a few other ways, even though it's only 1 year difference. There's quite a few little differences. If you wanted to look at them carefully, you will start noticing they're different. And you can't switch these front panels either, so even if I were to do that, I can't switch these panels. They don't actually plug into the back side because the LEDs and those blue LEDs aren't in the same place. And that was that. So that means ultimately I can't use this one because it's smashed up, and I wouldn't even be able to mount it in my Jeep. So I have to fix my old player. My next concept is the displays do look the same, and I was just going to pull the chips off, but look at the back. There's chips on one and not the other. On this one older model from the junkyard, the chips appear to be underneath here, the driver chips. And I believe that's pretty much where the problem is for controlling those cathodes. So what I'm going to do is I'm going to see if I can pull off these displays and find out which chip I want to actually replace this chip is where I think it is, because if I was looking really careful at those traces, if you look really careful, there's a via right there, and that via I think comes over to here, but I won't know until I get this off. And once I find out where that second, because there's actually two lines that come out to where it needs to provide the power, and wherever that little via goes is what's supposed to be providing power, the majority of the power when the vehicle just turns on. And the second one I think is just for when the headlights are on and it goes, oh, I have to dim this down, you know. And so I'm going to try and switch those chips out. I'll see if I get some footage of doing that. Now, as I've covered in other videos, if you have to desolder something, especially something with a lot of pins, there's a few ways you can do it. There's your solder wick. If you use it, make sure you have an iron that goes really hot and has a large tip, so you get lots of heat on it to suck up the solder quickly. Otherwise it takes forever and doesn't really work. So the key there is being hot. You can use your soldering iron to melt the spots and use a plunger. That works okay. Keep these really clean, take them apart, clean them often, and they'll work pretty good for you. But you got to be a little more fast. But what I favorite is I actually have it's a wand style, and it works the same as a regular plunger. And if you take this off and clean it a lot, make sure you keep it really clean and cleared out. These work really slick. It's got the heated tip, it's got a hole in it. You basically just treat it like a soldering iron and solder sucker in one, because that's what it does. See if I can show you one. We'll do that one right. It's on camera. Melt it and boom, got one right away. Got to keep them really, keep the tips clean too, and always take an eject away from your board so you don't spit solder, melted molten solder on everything. Okay, that's all. I don't remember many 40 or 50 of those there are. And there might be a few that are a little sticky still if I didn't get enough solder sucked out, and if so, I'll work back. But if I got it, then this should come out. And this heat stake is holding a little bit here. There, I got the two heat stakes out that they were using. There. It's off. Now, if these chips are exactly the same as my other one, we'll do the hot air rework station, and we should be able to use some hot air and lift this off and move it over to mine. I'd like to probably move this cap too. Well, we're going to have a little bit of a bummer luck job here. We got these two chips, and like I say, they're on the one from the dump yard or the wrecking yard. These chips are on the opposite side. One of these chips is the same exact part number, and because it's on the opposite side of the board, it's flipped. The other one does not have the same part number. The actual one I think is bad, is a different part number. It is not switched, but what it looks like they did is they got this different part number that actually has probably the pinouts in the opposite order, so that you could actually do a different type of pin configuration with the same exact silicon. So I've actually, by looking at how it's wired to the display, it's clear that it's a mirror image on the second chip. So I can replace these two, but not these two. And if this is the one that's burned out, we'll be good. If not, we're done. Okay, this is my hot air rework station, and it has this nice little pull-out wand holder, and we can work underneath that. Start by taking the other old one off. Start off by just generally heating the board up. We got our chip. This is the only one we can take off on this original board, so if it'll focus on that for you. So this one we're just taking off. I'm going to assume it's bad. I have no idea. Okay, now it'll focus for you. Focus. Oh. So we'll see if we can clean that up and use the other chip. Well, it doesn't want to focus, does it? There it does. See the lighting. Okay, I'm going to start off. I got it cleaned up, and I'm going to go ahead and just smooth out the solder a little bit on it. Okay, now I'm going to add some decent flux to this. We'll see if we can't get that chip down. Okay, let's see if I can start getting it to stick down now. Now, I don't know how much of that you could see. Yeah. I might have to check for a few bridges and clean up the pins a little bit. Get out my eyepiece and some flux and reflow it a little bit. But basically, I'm just fluxing each side and reflowing it to get a little bit of the bridges out. Because the air blew it around quite a bit. Kind of ran out of good flux while I was trying to center the chip. Took me a little bit too long. So a little rework is in order here. Yeah, there was no more bridges once I did that rework with the flux and the soldering iron. Now all we can do is plug it in, and if this doesn't make this thing to life, I really can't fix it. I don't want to go to the dump and get another radio and risk getting another one that doesn't go in. I can always just get a dumb radio. I don't have to have my original radio working. I'm just making this kind of a challenge project, really. But this other chip I can't replace. It's not the same as the other board. So let's plug it in and see what we got. Okay, we're ready for the test. I got my power supply set at 12 volts. And I've got it hooked in. I have the lamps off right now. I've taken the wire off and back for the lamps, just so we don't have the lamps. This display should work without the lamps. So let's give it a try. No, I do not see any display at all. Display did not come good. So it's the other chip. Let me try it with the lamp on. Okay, this is trying it with the lamps on. Nope. It must be the other chip, and I don't have any way of replacing that other chip. So, I mean, I can still get this to work. I just have to make my own 1 volt regulator. And I think that I'm going to turn the lights off here and see how bright that is. So let me try that. Oh, I'm not thinking that'd be too terribly bad at night. If I turn that down a little bit. Yeah, see, that'd get a bit hard to see even at night. I don't know if 1 volt is enough to see in the daylight. So before I actually decide what voltage I want to run this thing at, I have to actually take it out. I have to open the garage doors or walk outside with this rig and see how much light I need when I'm inside my vehicle. I might have to put the current, I might have to have something a little more voltage yet. It's hard to tell. But that'll be the next part. Making my own voltage regulator for that power, for that cathode, so that my display will work. Okay, so we got the display working, and now I got to calculate how to provide this voltage to make the display work internal to the radio. Now I got 12 volts coming in like the Jeep will always do, and I'm going to run that 12 volts out to where this red line is, but I don't want full 12 volts going across this. I only want 1 volt. And so I got to calculate how much of a dropper resistor I want and the power wattage that it's going to have to handle. So if I look at what I'm powering it with, I'm powering it with just about 1 volt and just about 100 milliamps. And that, if you do the V equals IR, that comes out to a 10 ohm resistor. 10 ohms of resistance. So there's basically only a 10 ohms of, across these power supply that I've simulated here, DC. So if I know that I have 12 volts coming in, I'm going to have 0.1 amps going through the whole circuit. If I measured the voltage right here, it's 1 volt across that 10 ohms, which is the cathode, or in anything else that I happen to be powering. It comes out to 10 ohms. So I have to drop 11 volts across some dropper resistor. And so what that comes out to, just V equals IR, is it comes out to 110 ohm resistor. Okay, so I have a 100 ohm resistor, and it's, you know, I can say here's a 100 ohm resistor too. You know, this is a 100 ohm resistor. Actually, sorry, that's 10 ohm. But let's say if it was 100 ohm. But the problem is what's the power that has to happen? I mean, if I'm dropping 11 volts with 0.1 amps, what's the power? Well, that's as simple as pi, P equals IV, IE. So I put in the 0.1 amps and the 11 volt drop, and that gives me 1.1 watts. So I got to have 110 ohms at 1.1 watt resistor. And this by the way is 10 ohms, but if this was even this big one, if it were 110 ohms, it would be this is only a half watt. This isn't a 1.1 watt. And I could, of course, do some more math and figure out how many, like if I could pull, say, 550 ohm quarter watts in parallel, well, then I could get the 1.25 watts and 110 ohms. And I could do that. It's close enough, and it would handle the wattage. But then you got a little cluster, and you're pretty much getting pretty dang close to, you know, you're driving at 1.1 watts, and you're only going to have 1.25 watts if you cluster those 550 ohm resistors in parallel. So what I rather do is I dug around and I found that I have a 100 ohm, which isn't 110, but let's say I don't care if it's a little brighter. And this one is actually 10 watts, and so this won't get hot hardly at all. Dropping 11 volts across with a 100, well, a 0.1 to a 0.1 to probably 120 milliamps tops going through this. So that is the way I'm going to do this, and I'm going to wire it up and stick it in here, and we'll see if it works. But just to let you know, I did think of other things. I thought about maybe an LM317 voltage regulator, but two things. One, dropping going 12 volts in and having 100 milliamps going through this and down to 1 volt. This produces a lot of heat. If you put that in the equations, which you can find in a book or online, you can really only get these down to 1.25 volts output, even though they're variable. This variable regulator has an internal reference of 1.25 volts, and so you really aren't going to get under that. And I need to get under that. I need to get down to basically 1 volt. And I did hook this up, and I did power it, and I did simulate my load with this 10 ohm resistor, and I had this jacked in, and this does get pretty warm, and it's not going to fit in here real good, so it's not going to work. It's going to be too bright, and it's kind of a complicated solution. And the last thing is almost for sure this voltage supply for this display is not DC. It's most certainly going to be pulsed current. It's going to be essentially a pulsing supply with a duty cycle. The reason they do that is because they can have a little micro in there, which is probably what one of those bad chips is, and it can actually pulse the 12 volts at a frequency faster than the human eye can see, and then it can provide the necessary energy for the display to work without the need for having dropper resistors and stuff, by essentially using duty cycle in the 12 volts. And that's not how all of these displays work, but that's almost assuredly how this one is working. I could get a microcontroller in there, and I could get a duty cycle, and I could program it to do basically do that. But I'm actually powering more than just what I thought, which was the cathode. I'm actually powering a few other things backwards, and maybe even part of that chip internally. I don't know. So I kind of put an X on the microcontroller, but that would have been nice, because then when I turn my headlights on, there's a sense pin back here that I could have sensed with the micro, and then I could have dimmed the display by changing the duty cycle, which is what it's actually originally designed to do. But because I'm not 100% sure how much I'm back powering with this current process now, and I know that this 1 volt 100 milliamps is definitely making my radio work, and I'm just going to not complicate it with a micro or voltage regulator. I'm going to just use a dumb dropper resistor, and I'm going to get my 1 volt 100 milliamps plus or minus probably 20 milliamps, well, plus or minus 10 milliamps maybe, is what I'm going to get for my display. My display will work, my radio will work. I'm going to try and wrap this video up by just making this dropper resistor, just basically dropper resistor, and then this 10 ohms here is just the cathode, or what I'm driving on the display. This part is essentially a display. So just this one thing, and I should have a working radio. That's the dumbest way to solve this, but it's going to work, and I'll drive it like, once I get the circuit made and button it all up, I'll drive it like this for a few hours to make sure everything's fine. Then I'll stick it back in the Jeep. So should wrap this up real quick. Okay, that was easy. I took a wire and I tapped onto the ignition wire, where when your ignition is on, then you'll have 12 volts coming in this yellow wire. The yellow wire comes down to this 100 ohm 10 watt resistor, comes out of there and goes into the display. It powers the display. Now notice I'm only hooking up to one side now. This other side over here is ground. That was probably what was causing me some of my headaches, is I kept assuming based on the traces that this was power and this was ground. But when I actually hooked this up, the voltage across my fluke over there said 0 volts, and all the volts, essentially all 12 volts were being dropped across this 100 ohm resistor. So it got pretty toasty really quick, but still it was only drawing about maybe 180 milliamps or 20. It wasn't that much. So it did get pretty toasty, but that meant, of course, that this was somehow ground as far as the chassis is concerned. This side of the display is ground, and this side is where this power voltage is supposed to go in. I'm not sure how that all changes what I was thinking. I could tear it apart and maybe figure out, maybe I was right about the cathode only needing power. It changes what chip I think is wrong, but oh well, I don't care anymore. I just want to get this fixed. I know that if I use this 100 ohm dropper resistor, I'm going to be able to basically just hook it up inside, run a wire over to the top of that display, and hook it onto that display, and then this is going to be fixed. And I'll actually, this doesn't even hardly get warm, but I'll go ahead and put zip tie it up to some metal and make sure everything is insulated properly, and then we should be good. Okay, here's the dropper resistor, 100 ohms, 10 watts. I've got it zip tied inside the case here to these left and right channel amplifiers that hook to this heatsink. So if there is a little bit of heat, there will be some heat, because it's going to be doing about 1 watt, and that will of course transfer through this just fine. It's going to hook into this yellow line here, which goes to the ignition. So as soon as the ignition comes on, then my display will get power of, on this side would be 1 volt, and right at 100 milliamps to 120 milliamps will go through this wire, and that goes up and is soldered on to the front of the display. Well, that's about it for this repair. It didn't go quite the way I'd like it to, but most repairs don't. I didn't have it quite figured out the way I thought I did, but that's okay. I got lucky and was able to make up some ground. I got the display working. The radio, of course, works flawlessly anyway. It's just the display. So I've got that dropper resistor in there. Try and keep the flames to a minimum. I know this isn't the right way to run this display. I know that if I took my time, which I already put too much time into this because I can just go blind to the radio really, but for the time I put in, I did pretty good here. I got the display working, got the radio working the way I want. It's a hack, but hey, hacks are cheap. You know, that resistor I actually got out of my bin of extra parts. It didn't really cost me nothing. Proper way to do this was to figure out the display a bit more, figure out exactly what was driving it, and get a micro in there, and like I said earlier, I believe do the pulse width modulation control of the duty cycle, I should say the duty cycle control, and then that would be the smart way to drive this display. But it would have taken a lot more work, a lot more. I would actually have to for sure take off the display and trace out the traces, even knowing the chips wouldn't just help. I had the polarity wrong, like I said. That was really messing me up a bit, but I didn't want to go back and redo that work because the display is working, drawing in 100 milliamps off my dropper resistor, which can handle 10 watts, and I'm only going to be pushing about 1 watt, 1.5. And so that's a perfect good solution. Sometimes it's just, you're just trying to fix something, you just want it to work, you don't want it perfect, and I've got a lot of other things I want to play with. I don't really need to, try and stick a micro in here and get it doing all that fancy stuff again. Because there is a chip in that's supposed to do that. If I wanted to go that far, I could probably see if I could order those chips and get them in. Because I could very well do that. But then I got to buy, $2, $3, $4, $5, $10 chip. I don't know what it'd be. Or I have to go dumpster diving at the wrecking yard again and try and get some more. But that said, I probably could just, pay another $17 and get another one and pull the chips off of that. But who knows? Flame me if you want for the solution. It's the voltage divider. I'm simply using a dropper resistor to get down to what I need for the power of the display. I hope you found it useful and interesting. Sometimes the icky way to do things is the easiest and cheapest way. And here you can do it. So if you followed this whole video, kudos to you for being able to manage to watch this whole video. But there you go, working the radio. I'll stick it in the Jeep. I'm going to run it here for a while and make sure everything's fine. Then I'm going to stick it in the Jeep and we should be done. Well, I know it's dark out, but I thought I'd show it back in the Jeep. I'll go ahead and hit scan, run AM, and switch to FM. And it's scanning, and I have a display. And that's it. All done and working. Thanks for joining.